Everyone. My name is Manan Baria, and on behalf of my fellow project scholars, I will be presenting our research study, that is experimental analysis of strength and durability properties of cement binders and mortars with addition of microfine sewage sludges. We have done our project under guidance of Dr. Niragi Dave, and our project was funded by SRP PDEU. So the content of the presentation is, first of all, we're talking about introduction, the objective of the study, material and the methodology, result and the discussion, and finally the conclusion. Introduction. So first of all, we'll be talking about the problem statement that we have taken in our study. Sewage sludge is a byproduct of solid waste treatment plant, and we have seen that with increase in the population, the generation of the sewage sludge increases. Now the volume of the sewage sludge is becoming unmanageable for the authorities. In current practices, we have seen that the sewage sludge is either used as a landfill or it is dumped in the on ponds, which results in the environmental pollution. So what to do then? So the solution that we have proposed is, first of all, we will be taking this sewage sludge and we will try and pulverize it and process the sewage sludge to the microfine size, and we will use that sewage sludge as a cement replacement, and we will be utilizing it in various construction applications. So the objective of the study is, first of all, to measure the physical and the chemical properties of OPC, ordinary Portland cement, and sewage sludge, to measure the comparative strength of binders and mortars, and to investigate the chlorine ion permeability of the concrete prepared from sewage sludge, ash, and cement. So the methodology that we have adopted in our study is that, first of all, we have taken sludge from STP plant, but the sludge we obtained was in a very wet form and contains very organic material. So we have to incinerate it at very high temperature in a furnace, and then after we have pulverized that dried sample to microfine size using planetary ball mill. Then we have conducted chemical analysis and physical property tests like fineness test, setting time, specific gravity test, and consistency of the sewage sludge S. Then we have prepared the binder and mortar samples using cement and various replacement proportion of sewage sludge. The replacement proportion that we have used in current study is 5%, 10%, 15%, 20, and 25. Then we will prepare when we will mold and cure the samples for 7, 14, and 28 days, and then we will conducting some the test on the prepared sample like microstructure analysis test using XRD. Then we will also conducting durability test like rapid chlorine permeability test, which which shows the performance of the concrete under a chlorine environment, and then we will be doing compressive strength test on binder and mortar. So these are the result of chemical composition of sewage sludge ash and OPC. So from the result we can see that sewage sludge contains high amounts of silica, that is 60.34, and sewage sludge ash is high in silicon content. These are the result of particle size distribution. From the result we can see the mean diameter of sewage sludge ash comes out to be 24.14 after pulverizing it. Now talking about the consistency test and setting time of sewage plus sludge binder, we have conducted this test as per IS 4031. From the result we have seen the addition of sewage sludge as from microfine size requires more water for attaining desired consistency in comparison to concrete. That with increase in the value of replacement of sewage sludge, we have to increase the amount of water in order to maintain the consistency. And talking about the setting time, we have seen that with addition of sewage sludge as pozzolanic reaction occurs, which increases the setting time of the binder. Talking about the comparative strength of binder and mortar, we have conducted the test as per IS 516-1959. So talking about the binder mix, with increase in the curing period, we have seen an increase in the strength of the binder mix, and the highest strength gain was for binder at 15% replacement of OPC by SSA. Due to the presence of microfine SSA in the cement, when mixed with water, it makes a highly viscous binder which significantly enhances the compressive strength of the binder. And talking about the mortar mix, the result presented shows the maximum increase of 7.2 in compressive strength test uh, with addition of 10% SSA and for 20 days of curing. Further addition, however, showed a lower value of compressive strength, that is with increase in the addition of SSA in 20%, the quality of the quality of the OPC suddenly reduces and the compressive strength of mortar deteriorates with increase in the more percentage of SSA. Talking about the durability, we have conducted RCPT rapid chlorine permeability test as per ASTM C1202. Rapid cooling permeability test determines the resistance of the concrete to penetration of the chlorine ions, which are one of the major sources of corrosion of the reinforcement. So the RCPT result shows that the substitution of OPC with pozzolans result in a considerable decrease in the permeability of chlorine ion. The permeability value of mortar mix reduces by 26% to 28% after 20 days and 25% after 90 days. Now talking about the XRD analysis. First of all, XRD analysis is utilized for the characterization of material properties such as its mineral phase determination, crystal structure and crystalline size and strain, etc. The XRD spectra of SSA presented in the figure shows the presence of silica and anthracite as major phases. Calcite, albite, muscovite and compound containing alumina, silica and magnesia were also present. So the conclusion of the study is that the best result in compressive strength of mortar and binder was achieved with 10 to 15% replacement of OPC 53 by microfine sewage sludge. This percentage can be taken as an optimum percentage of replacement of sewage sludges. 10 to 15% of partial replacement of OPC with SSA shows an increase of 15% in initial and final setting time, which develops better compressive strength with 20 days of curing time. Water absorption of binder blocks increases with addition of sewage sludges because higher quantity of finer material present in the mixture. The substitution of OPC with SSA results in considerable decrease in the value of chlorine ion permeability. And on the basis of compressive strength test, the highest gain in the mortar was found to be at 10%, and for the binder, it comes out to be 15% of OPC by SSA. So thank you everyone. First of all, we would like to thank the SRP PDU for their immense support and the funding that we have provided. And we would also like to thank Dr. Niragi Dave for their immense support during our project. Her experience and deep knowledge in this field help us to successfully complete the project, and we were able to publish our paper in a reputed journal. Thank you.